Alright guys, sorry, I don't know what happened with the last video, so we're just going to kind of pick up from where we left off. In terms, again, of strength versus concentration, concentration is all about the moles of the acid or base that's present in that solution in a specific volume. So concentration and dilution, all about moles and volume. So about that molarity. But this is different than what we call a strong acid or a weak acid, because strong and weak acids are dependent on the ionization of that acid or base. So if I have a complete dissociation, a complete ionization of my acid or base, that is a strong acid or a strong base. But if it doesn't completely ionize, if I get only a few ions present in my product, that means that I have a weak acid or a weak base. Now, the next two problems we're going to skip, and again, I'm going to post on your blog a couple practice problems for you to write Ka constants and then Kb constants, and then I want you to try those maybe over the weekend, and then I will give you those answers to those on Monday. So I'll also post them on the blog, but I'm not going to post them until Monday because I want you to try them first. In section 4, that's our last section of this chapter, I am eliminating slides 64 through 75. That's a lot of slides, I know. But I'm eliminating them because I think we understood the bulk of what I want us to take away from acids and bases so far, and I think that your test is already covering quite a bit of material. So we're going to eliminate those last slides there. So 64 through 75, you just make a big ol' X through those. We don't need them. So really in section 4, the only thing that we're going to talk about is neutralization reactions, and then I also just want you to understand very simply what a titration is. Now you will do a titration on Friday, and I know you're watching this video after you do the titration. So you will have already done the titration. So hopefully you can understand or explain to me what a titration is and how it works or what we do in a titration. Okay, so in an acid-base reaction, when an acid reacts with a base, water and salt can form. That is called what type of reaction? Neutralization. So in a neutralization reaction, that occurs when I have an acid and a base reacting to produce water and salt. So there are some properties of this. Acid-base reactions occur all the time in everyday life. One example would be when my stomach hurts and I feel like maybe there's a lot of acid reflux going on. I may eat an antacid, and that will help neutralize the acid, that hydrochloric acid that's in my stomach, so then that way my stomach isn't producing as much acid. It's neutralizing that. So maybe it's not as sour anymore. I can also use a neutralization reaction or acid-base reactions to adjust soil pH. So a lot of gardeners will try to neutralize their pH. Oftentimes soil is a little bit too acidic in gardens, so a lot of people will add some type of calcium carbonate or Epsom salt to their soil, so then that way they can get it to be less acidic. And then finally, another good example of this, if we think more medical terms now again, would be kidney stones. So oftentimes kidney stones can help, we can at least get them to pass through your system by adjusting the pH of your kidney. So a lot of times we can give you some type of salts, so then that way your pH in your kidney can adjust, and then we can get those kidney stones to be passed. And I've not had a kidney stone, but I've heard they're pretty painful, so we want them to pass as quickly as possible. In a neutralization reaction, again, it's when an acid and a base react in an aqueous solution to produce salt and water. So there are two examples that I gave you here. The first one is hydrochloric acid reacting with sodium hydroxide to produce sodium chloride and water. So I have an acid and a base producing a salt and then water. Another example would be sulfuric acid reacting with potassium hydroxide to produce potassium sulfate, and then I also have water that's made. There is a big key in this neutralization reaction in that you have to notice that the bases all have what here? Hydroxide. So a neutralization reaction, in this neutralization reaction, so that way we can produce water. Our base is going to need hydroxide. So when we're looking at this, for us, our neutralization reactions should kind of follow then Arrhenius's model of acid-base theory, where acids contain hydrogen and bases contain hydroxide. So then that way we can produce water. So in neutralization reactions, acid-base makes salt and water. Okay, in a titration, which you will have already done this lab, so hopefully this will just kind of be a little small review just on this slide for you. So titration is a process of adding a known amount of a solution to a solution of an amount or a concentration that we don't know. Oftentimes we can do, let's say we know the concentration of an acid, but we don't know the concentration of a base. I can find that by doing a titration, or I could do it vice versa. Let's say I know the concentration of the base, I want to figure out the concentration of the acid, so I can do a titration. And in a titration, we know that we use a color indicator because a color indicator will tell us what the equivalence point is. In a titration, when we reach the equivalence point, this means that the amount of moles of hydrogen ions will be equal to the number of moles of hydroxide ions. In this case, we're trying to neutralize that solution, that mixture of the acid and base that we're getting together. So equivalence point tells me when I've reached neutralization. Now, when we do a titration, it's easy for us to see it because we add a color indicator. In your lab, you added phenolphthalein. So when we added it to one solution, it was clear, but then when we started to add that base to it, once we knew that we added enough base, it started to turn pink. And then once it reached that pink color, we reached the equivalence point. So that's where I want to stop here. Like I said, the rest of your notes, we're just going to kind of forget about them for now, because really it's just more about titration, a little bit about salt hydrolysis, and then there were like 2 slides on buffers. So I think we have enough information for your test for Wednesday. So if you have any questions on this video or the video that was before, just post on the blog or email me, and we'll have a review day on Monday, also review day on Tuesday, and your test will be on Wednesday. So again, any questions, let me know. I hope you guys have a really great weekend. Bye.